Okay, numbers 2 and number 4. Remember number 2, 1 over x had vertical and horizontal asymptotes here, so the graph looked like this. Okay, so what this does is the 4 is kind of a stretch. We didn't worry about that too much. And then the minus 3 just shifted everything down 3. So our horizontal would be here, our vertical was here. Now if it shifted right and left, it would be under here, right? X minus 2 and shifted plus 2. And our graph would look like this. Okay, so thinking about that transformation and the asymptotes. Okay, x squared, remember, looked like this. It had an asymptote here and here. And if it's plus 1, just shifted it up 1. So it didn't move anywhere right and left, or else that would be inside there. So it'd be right here and right here. Okay, number 6, we're going to find all the asymptotes to graph this. So our vertical asymptote, remember you set this 2x minus 1 equal to 0. So add your 1 and divide by 2, you get 1/2. The horizontal asymptote, remember if they're equal degrees, they're both degree 1. It's going to be that y is equal to 4 over 2, which is 2. So our graph is going to have a horizontal at 2 and a vertical at 1/2. Okay, so our graph then looks like this. Okay, the homework didn't ask you this, but how do you find your x and y intercepts? Okay, so our x-intercept, I'll probably ask you this on a quiz or test. Our x-intercept, remember you set your y equal to 0. So if you set this equal to 0 and cross multiply, it's basically this top part. You set 4x minus 3 equal to 0. You get x is equal to 3/4. Okay, so right there at 3/4 is your x-intercept. Y-intercept, you set x is equal to 0. Okay, so you put 0 here and here, you get y is equal to -3 over -1, which is at 3. So right here at 3 is your y-intercept. Okay, number 8 is y, where f of x is equal to 2x over x squared minus 1. Okay, so our vertical asymptote, set the bottom equal to 0, x squared minus 1. You can either add the 1 or if you factor, it's x plus 1, x minus 1. So x equals -1 and 1. So we know we have asymptotes at -1 and 1. Okay, our horizontal asymptote, when it's larger on the bottom, it's the degree, x to the first, x to the second, is always at y equals 0. Okay, to find your x-intercept, set this equal to 0, so you get 2x equals 0, so you get 0. And the y-intercept, it's going to be the same place here at 0. Because you set all these equal to 0, so you'd have 0 over -1, which is 0. Okay, this one you might have to go to Desmos to kind of get a graph of it, unless you realize what it is. So it looks like this. Okay, so there's your graph for number 8. Okay, for vertical asymptote, set the bottom equal to 0, so we know there's going to be 1 at 0. So vertical asymptote at 0. Horizontal asymptote. Okay, so when it's larger on the top, we know it's going to be oblique. So I have to divide x into x squared and x squared minus 1. So it'd be x, and x times x is x squared. Those cancel out. Nothing times x is -1, so it'd be like -1 over x. Okay, so but we ignore that. We just use y equal x, and we ignore that part. So our horizontal or oblique asymptote is at y equal x, which would be this line right here. Okay, and our x-intercept, we set our y equal to 0. So it's basically x squared minus 1 equal to 0. So you get 1 and -1. So we're going to have asymptotes, x-intercepts right there. And the y-intercept, set the x equal to 0. So those are 0. So you have -1 over 0, which is undefined. So, and that makes sense, right? Because we said there was going to be an asymptote here on the y, so it's not going to be there. So there's no y-intercept. Okay. So when you graph this, then it looks like this. Okay, since we have the going through there and we have the asymptotes as our guide. Okay, number 12. Maybe hopefully you'd realize this, but this would be if you factor this x plus 1 and x minus 1 over x plus 1, those would cancel, so we just have x minus 1. But it still means we have a whole, right? Okay, so our function, you start at negative 1 and go up 1 over 1. Okay, so our line's going to look like this. Okay, but we still have a whole. It's not really a vertical asymptote per se because it cancels out. But if I set that x plus 1 equal to 0, I get x equals negative 1. So right here at x of negative 1, it's an open circle. There's a hole right there. Okay, and that's our graph. Okay, number 18, we're going to solve this. We're going to multiply by the common denominator. So 2x plus 5 and x plus 2. So this would be left with 5 times x plus 2 is equal to 3 times 2x plus 5. Now, same idea as if you notice it's one ratio equal to another, so you could cross multiply as well. So we get 5x plus 10, 6x plus 15. So subtract that, x equals negative 5. Okay, so we have our solution that x is equal to negative 5, and it works in both. We check that. Okay, now we want to know where this one's less than this one. So remember we kind of create this idea here where it changes. Okay, so I know negative 5 is going to be one of those places where it changes, and also where my asymptotes are. So this, if I set 2x plus 5 equal to 0, I get negative 5 halves, and I get negative 2. So this would be negative 2.5. Okay, so we have to check all these different areas here. Okay, so let's say I take, I don't know, let's say I take negative 10. Okay, if I plug in negative 10 for the x, that'd be an area, this area down here. So it'd be negative 20 plus 5 would be negative 15. 5 over negative 15 be negative 1/3. And on this side, negative 10 plus 2 would be negative 8, negative 3/8. Okay, 3/8 is going to be 0.37. So that's going to be more negative than this one. So this is going to be where it's greater. Okay, so that's going to be this one over here. This side is greater than this side. Okay, so I know the greater part would be from negative infinity up until negative 5. Okay, it usually alternates, but let's just check and make sure. Take a number in between here, like negative 4. Okay, so 2 times negative 4 would be negative 8. Negative 8 plus 5 would be negative 3. And then this side, negative 4 plus 2 would be negative 2, be negative 3 over 2. Okay, so 5/3 is negative 1.6 repeating, and this would be negative 1.5 repeating. So which one is the greater one? Okay, like this, right? So okay, so this side is less than this side. That'd be part B. So part B is from negative 5 to 5/3. Okay, and then plug a value in here. Okay, and from here to here, that'll be this part over here. Negative 5 halves and negative 2. And so this is less, this is greater, this is less. Okay, and then over here from negative 2 through infinity also works. Okay, so that's number 18. Number 19, multiply both sides by x plus 1. I get 3x minus 2 is equal to 0. So I get x is equal to add the 2 and divide by the 3, 2/3. Okay, so that's my solution. It does work here. Negative 1 is the only one that won't work. Okay, now thinking about this greater than less than stuff, we know at 2/3 there's a change because that's where it's 0, right? So on one side of it would be positive, on the other side negative, one way or the other. Also at the asymptote, okay, so x plus 1 equal to 0, so x equals negative 1. Okay, so we have three different sections to test here. So something less than -1, okay, like -2, let's say. So 3 times -2, so at -2, that'd be -6, -8, -2 plus 1 would be -1. Okay, so we have -8 on this side and 0 on the other side. So -8 is less than, right? So less than would be this part here. So from -infinity to -1, it's going to be this one. I'm sorry. This would be -8 over -1, which would be +8. And 8 is greater than 0. So that goes over here. I missed a sign. Okay, pick a number between here, like 0. Plug a 0 and a 0 in there, you get -2. Okay, if I plug a 0 in, I get -2 is less than 0, so it'd be on this one here. So from -1 to 2/3. And then from 2/3 to infinity, pick any number in there, like, let's say 1. So I plug a 1 in, 3 times 1 is 3, 3 minus 2 is 1, and 1 plus 1 is 2 on the bottom. And 1/2 is going to be greater than 0, so that's over here. Number 20, multiply everything by x squared. So that gives me x squared minus 5x plus 6 equals 0. Okay, I want to solve it. So -2 and -3. So my x would equal 2 and 3. Okay, now do they both work? Yep, 0 would be the only thing that would not work there. Okay, so if I think about the asymptotes, they would be at 0. So I have to check 0, 2, and 3. Okay, so I got to test all those there. So take a negative number, like -1. Okay, if I plug in a -1, let's see what happens. I'd have 1 minus, would be +5, because that'd be that. -1 squared would be 1 plus 6, that'd be 12. Is 12 what than 0? 12 is going to be greater than, so it'd be over here in part C. So from -infinity to 0. Okay, the second part is 2's number in here, like 1. So we got 1 minus 5 over 1 is 5. 1 squared is 1 plus 6. So that would be 2. And 2 is also going to be greater than 0. So that goes over here as well, from 0 to 2. From 2 to 3, let's take like 1.5 and plug it in. Okay, so 1 minus 5 divided by 1.5 plus 6 divided by 1.5 squared gives you 1/3. Okay, 1/3 is also greater than 0. So sorry once again, a number between here and here is not 1.5, it's 2.5. Alright, and if you plug in 2.5 into that equation, okay, you get -0.04, which is going to be less than 0. So between 2 and 3, it's going to be less than 0. Now, since 2 and 3 are actual answers where they can work, not asymptotes, we're going to use the brackets here. Also here I should have used a bracket as well. 0 was an asymptote, so it can't equal. That's why I have that one there. Okay, something above 3, like 4. Okay, it'd be 1 minus 5/4 plus 6 over 16. That's going to give you a positive number, which is going to be greater than 0. So once again, from 3 to infinity, you're going to have it greater than 0 as well. Okay, number 21. So start by factoring your denominator there, x minus 2 and x plus 1. So that's what I'm going to multiply by. So when I multiply here, those cancel. I'll have 3 and x plus times x plus 1. Here, those cancel, so I'll have 1 times x minus 2. And there they both cancel, so I just have the 1 on top. So I solve this. Okay, so I get x equals 0, and 0 will work in all of my denominators, so that's my solution. Okay, so where am I going to have to test? Okay, I'm going to have to test at 0. Set this equal to 0, I get 2, so I'm going to have to test at 2. Set this equal to 0, I'm going to have to test at -1. Okay, so I have a couple places to test here. Okay, so yeah, when you take them and plug them in, I'll just kind of tell you between -infinity and -1, take a number, any number negative here that works, and it will this side will be less than this side. So right here, -infinity and -1. Between -1 and 0, this side's going to be greater than this side. So we have this one here. Okay, now 0 is a solution, so that can work. -1 is not. Okay, and then a number between 0 and 2, like you plug in 1, this side is going to be less than this side, so that's right here. And then the last section here from 2 to infinity, that's where it's going to be over here. Okay, number 22, we want to know where it's equal to 0. So right here at this x is 0, so that's at -2. Where is it less than 0? So all these numbers have y's that are less than 0. So from -2 through our asymptote here, which looks like it's at -1. So from -2 to -1. Where is it going to be greater than 0? So here's greater than 0, and here's greater than 0. So from -infinity to -2. And then also said here, so from our asymptote, from -1 through infinity. Okay, where's the absolute? Okay, so oh, this is a little tricky. Absolute, if you remember back in, I forget what section we did that, absolute value. So absolute value just makes a positive, right? So all these get flipped up right here. Okay, so it's going to be positive all the way here, all the way here, and all the way here. So it's always going to be greater than 0. Except we have this asymptote, right? Okay, and it's going to be equal to 0 here. So we're not going to include that. We're not going to include the asymptote. So not at -2 and not at -1. But here, between those two, and then after as well. So, so from -infinity to -2, and from -2 to -1, and then from -1 to infinity. Okay. 31, it says y is inversely proportional to x, so divided by x. It says y is 5, x is 6, plug them in there, solve, you get k, and then plug in the k value with the other known value that's missing to solve for your y. 32, it says z is inversely proportional to the third power of t. Okay, so then you put your z and your t in there, and you cube that and multiply here, like you can cross multiply d, you get k is 10. Plugging in the values that you know, finding the z, and it gives you 1.25. 33, it says it's jointly varies jointly with n and the square of p, and inversely with the cube. Plugging your values in there, solving, you get 2. Then taking the values that you solve, m is equal to the k, plugging other values in, you get 847. 36 says the resistance varies inversely with the square of the diameter. So you put in the resistance and the diameter, you get a k as this. And then we want to know what if the diameter is reduced to be 0.03, or I'm sorry, increased. So we plug that in and you get your answer. 38, it says the force is inversely with the radius and jointly with the weight of the car and the speed squared. So you put the force, the weight of the car, the radius, and the speed squared in there, solve for your K. Then you plug stuff in. If we're using the same car, so it's still 2,000 pounds, we got your K now from there. Our speed is 60 and our radius is now 800. We need a force of 7,500. Okay, the load that it can hold is equal to, directly with the fourth of the diameter and the square of the height. Plugging the values in, you solve for K. Using that K and the new values, you get a new load of 8/9 or 0.8 repeating